start recording. Okie dokie. So when we left off, we just finished doing these lines. And so, that's right. I was saying that we might get into pixel shaders today, but I'm actually, since like doing the prep for the lesson, I'm thinking we might save that because it's a bit of a bigger topic than I really think we should get into right now. But so what I will get into is we will finish off the lines and put the like little end caps on. So let's get whiteboard underway. So from memory, what we had, well, let's say we have 2 points that we want to draw a line from. We have the start and we have the end.
Oh, I can't see you on
Something
your
has
OBS
gone.
screen.
I should be
I
sharing.
see me.
Oh no, yeah. No, I have to take that down because the webcam goes through OBS, like, because this is what I'm recording. So if I go webcam, obviously I'm not recording.
Oh, never mind. Oh
Yeah,
no, never mind.
I
I actually just had the Google Hangouts was on the wrong thing.
oh, okay,
That's all it
that
was.
makes more sense. Yeah, no, I wish I could get webcam across, but no, it's a little too much to ask of Google. So what we were doing is we wanted to draw a line, and we figured out where these 4 points are, and we turned that into, I believe, that, and we had like vertices 0, 1, 2, and 3, and that's what we were doing. So is that, are you happy with that? All familiar?
Hmm.
So what we wanted to do today was just expand on that. So when we draw our line, instead of like that and shading it in, we wanted to stick some nice round end caps on it. Just sort of, and this will be sort of revision and discussion of a few things, and like textures and stuff, and then later on we might convert it to a pixel shader or something nice. So the way we do this obviously is, we've got like these 3 sections here. So what we're going to do is we're going to tack on several more vertices onto our line here, and so what we need is we have let's have a look at the code for a little bit, and talk about how we might convert this. So down, all the way down here is where we're adding this vertex data, and so we've got like the line vertex, and we're taking this P, which is just straight up this vector here. In fact, I'm just going to make a minor adjustment there, and this is one of those things because we're, y is down, x is across, in that space for the time being. So this is our P vector, so P for perpendicular, and we're just building up just, these 4 points. So what we need to do is we need to build these other points. Let's draw them in a different color. There, and there. So what we need to do is we need to go along this vector and along that vector, which obviously are the same vector, just mirrored, and then go down by P. So we'll call this one like N for normal, let's say. So we need to, that's the math that we need to get this shape so far. So are you happy with that?
Yeah, I mean, yeah, perpendicular memory is weak, but I'm following you so far.
Yep. So this should now be fairly sort of familiar vector addition stuff. So what we're going to do is we're going to just slightly adjust, because you remember we had 0, 1, 2, 3, for the vertices, we're just going to make this a bit simpler. We're gonna renumber them. We're gonna call them 0, 1, 2, 3, 4, 5, 6, 7.
Why did you change the order?
Well, because when we're going around, like when we were just doing 4, it's like, that one, then 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 that one. It's not sort of a, it doesn't become a mess. Whereas if I numbered them in the same way, sort of going around this way, it would be like 0, 1, 2, 3, 4, 5, 6, 7, and then suddenly I've got a triangle 0, 1, 7, 1, 6, 7, 1, 2. It's just a wee bit confusing. It's kind of arbitrary, but
Okay.
it just makes things neat. And to a lesser extent, like for something like this, I think it makes no difference whatsoever. But for if you maybe had a bigger model, you might want to try and keep them sort of like the locality of your triangles, if you know what I mean. Like because you recall, like, all the vertices are in this array, and if we're fetching like 1, 2, it's like 0, 1, 3, 2, 1, 2, 3, and so on. That's all like just grabbing from this section. And so if there's any caching mechanism going on, that keeps things all local. Whereas if I'm getting the triangle for like 0, to 12 or something, or heaven forbid, like 1000, then suddenly I'm having to bring in like this chunk of the vertex data as well.
Yeah, that makes sense. I think I got that part. I think I misspoke and just said I saw, like, I thought the 2 that you have now would have been 1, the 3 you had would have been 2, and the 1 you had would have been 3. That's all I meant.
Yeah, that's okay. It's just I've decided just to build the whole thing in that direction.
Okay.
But yeah, like I said, it's actually pretty arbitrary. It's just when I was doing this in my little practice run, it's like, that gets confusing. So what we're going to do is we're going to basically build that now, and then we'll start texturing it in the next step. So let's... Okay. Oh, sorry. One sec. I've just dropped my tablet on the floor. Oh, dear.
I hear that's good for the resale value.
Yeah. Hopefully it still works. Is it tracking? It's tracking. Good. Okay. So where were we at? We were going to expand on this. So we're going to basically go through this program and, first of all, increase the size of the buffers we're working with to match this diagram. So we've gone from 4 vertices to 8 vertices, and we've gone from 2 primitives to 6 primitives, and we've gone from because we've gone from 2 to 6 primitives, we've gone from 6 to 18 index buffer entries. So we're just going to scroll all the way through and just look for stuff we're doing. Now, our load content stuff was unrelated. We've got this load line drawing content, so I'm pretty sure we can just scroll all the way down to past everything we did here, down to line drawing. Yeah, and that's all good. So we can go all the way down to this like vector-based lines. You don't have that same comment, but that's okay. You've got the same sort of stuff. So max lines is going to stay the same. And this is sort of an interesting point with, like, you know how it's sort of considered good practice, like, points, indices per line is, it was 6 and now it's 18. And if we'd done it that way, we could adjust this quickly. But I'm going to say it's not worth doing, and that's because this is such a small self-contained piece of code. It's like, yeah, of course there are, that many indices. So, like a hard-coded value that you're never going to change, and that anyone sort of reading and understanding the code is going to know, that's it's not something you really want to worry about too much, and it kind of clutters the code, because it's like, why would you change that? Why would that be not just be hard-coded? It is a matter of taste. So I will fix that up though, because that should be max lines. So we have vertices. Now we need 8 vertices instead of 4 per line. Over here we need 8 vertices instead of 4. We need, this is our index buffer, we need 18 per line. Is that correct? 3 times 6 is 18, yes. And obviously this one here. And then we get to here. And so now this is the bit where it's like, well, it obviously doesn't matter because it's hard-coded, because this is the other part of the reason it's like we're not going to worry about making a little constant for this, is that we actually have to fill this in anyway. So this should now be 18. So let's fill this in. 5, 6, 7, 8, 9, 10, 12, 13, 14, 16, 17. And of course, the number of vertices per line has changed, so we have to up that one to 8.
Yay, for typing.
It's really the easy bit, because it's like we know what these are. So we just need to enter this. So and because we've gone 0, 1, 2, 3, 4, 5, 6, 7, and all of our triangles are like the same shape, this is actually really sort of easy to do, hopefully from sort of memory. So it's 0 to 1, and then you start at 2, 3, 1. So let's just check we've got that correct. 0, 2, 1, 2, 3, 1, and then it's the same pattern for another 4 triangles with just increased indices. So what would that be? That would be 0, 2, 1, 2, 3, 1, 2, 4. Yeah. Okay. So 4, 3, 4, 5, 3, and then the last one would be let's look at the diagram. 4, 6, 5. 4, 6. Oops. 6.
6, 5, 7.
And then yes, 6, 7, 5. Because we've got the clockwise winding order, so we'll just check that against the diagram. But I'll check the middle set against the diagram. So it's 2, 4, 3, 4, 5, 3, and then this one is 2, 4, 3, 4, 5, 3. So those are looking great. So and as long as we have
Wait, sorry, can you show me the diagram again?
absolutely.
So, yeah, okay, yeah, sorry, I'm good.
Okay, so are you happy with those?
I think so.
2, 4, 3, 4, 5, 3.
4, 6, 5. Yeah, no, that's right.
Okay, that looks good. And if we've got them wrong, we can always debug them. We'll be missing a triangle out of our thing, and obviously we check we have all 18 indices specified. So let's keep going down. I'm going to skip over line and leave that to last, and we'll just finish this finish vector lines part of it. So we're setting the data now. We have 8 vertices per line, and so we have 8 vertices per line, and then we have this one here, and that's primitive count, so we have 6 primitives per line. So that should all make good sense. So let's finish up this line here. So let's simplify this code a little bit. So let's look at the diagram we drew. And you can see here, we're basically building it out of two vectors that we're getting from sort of the line thickness. So thickness there. And these two vectors, start and end. So we've already got start and end. So all we need to do is create P and N. So let's simplify our code out a little bit and make this happen. So there P equals do you want to take a crack at this one before I fill it in? Actually, sorry, let me simplify this a bit. Try N first, actually. So I'll just bring up this diagram.
N is the normal that's from the mid of the.
So in fact, I'll modify this diagram to be a bit more clear. So this is N. Oops, why can I not have color? This is N, and this is negative N. So
Okay,
N.
so
Yep.
no, just maybe just keep the diagram up.
Yep.
But I'm trying to think.
Where's my diagram? There we go. Just gonna bring it over.
So I'm trying to produce a vector that is perpendicular to the vector of 4 and 5, right? A normal. It is a normal, is it not?
Well, 4 and 5 will be derived from N, so you're actually sort of going in not quite the right direction there. So
yeah, I need a help with that. I'm not sure where to begin, to be honest.
So
like it's been too long.
That's okay. So we've got this vector here. We can easily derive that, and you've already done that. That's line in the code. Oh, sorry, it's V in your code.
Oh, okay. That code's different than yours. Okay, so V. Yeah, right. That's just sure.
So from V, it should be fairly straightforward to get N. So do you want to take a crack at getting N from V?
How? Okay, sorry. How is it straightforward? I mean, I guess it's like V plus T, right? Because the only thing I have is like I need to extend V. No. Or is it the normal of V times T?
Pretty much. Yeah. So the normal of V will be, let's go dark profile for this one, will just be some vector of length.
0, 1, or 1, 0. Or,
length
yeah,
1.
sorry. N hat is...
And so all you have to do is multiply it through to change its length to whatever particular length you want. And
right.
So obviously in this case you want 0.5 T. Yeah.
Oh, why is it 0.5 T?
Because T is this whole thing, because that's just how we've
right.
We've happened to have done it. So that should be fairly straightforward. So do you want to just type that in and check we've got it?
Yeah, sure. So vector 2 normalize doesn't matter, does it?
So I would
just be line. It'd be start minus. Sorry, go ahead.
Yeah, you've got it. N minus start is sorry.
Yeah, same. Well, yeah.
Yeah.
N minus start times. Well, it's the same as this guy, isn't it?
Yep. And so let's redefine P now, because we can generate P in terms of N very simply. So do you want to just this should be
and this junk here is I'm just gonna oops.
Yeah, if that makes it easier for you to think about it, that's
does,
fine.
unfortunately. Yeah.
That's fine.
Forgive me.
No. That's cool.
All right, so this is just the perp of N, is it not? I mean,
yes.
We're doing all the same math, so
because yes, so like we've got N there, and it's like this is a horrendous drawing.
I mean, it's simple now when I'm looking at it. Now
It's
it's just
P.
now it feels stupid. But
Oh,
okay, yeah.
well,
The perp of n, yeah, which is the normal of v, which is the length of the line, and the thickness is where we get a half of. Yeah, to get the end caps, we want half the t. Okay.
yeah. Okay, so that's I see. I see. Yeah, yeah. Because um, I think I understand where you missed that. That's a good color. Let's go red. So because this is a circle and allegedly a circle, the radius of P, which we know is half of T, is going to be the same radius of N. So N and P have the same length, and so that's sort of the formula that we needed to be thinking about. But yeah, because I didn't sort of make that clear what N represented as part of a circle was maybe sort of
Yeah, but we
step
talked
that was
about it
missing.
enough before. But yeah,
Yeah. Well, now
yeah,
you know. I think it's like, that's fine. It's like, now I understand. It's good. So now we have that. All we have to do is build up all 7 vertices from P and N, and once again, the way that this is done, 0, 1, 2, 3, 4, 5, 6, 7 makes this a little bit easy. So let's do that now. Let me just catch up to you. N equals most of that one. So let's get rid of those because we're just gonna do this straight in line because we have enough vertices that we don't want to just be defining local variables and then not using them. So
we've got 8 there. We need. Oh yeah, we do need 8.
Yep. So if we look at our diagram, the first 4 are based around the start, and the second 4 are based around the end. So let's put that in. Let's start from that position. Now, if we look at the diagram again, the first 2 have this negative n on them, and the last 2 have this plus n on them. So let's stick that in, and hopefully that's making sense so far. And then finally, we've got this kind of pattern. It's like 0 is minus p, 2 is minus p, 4 is minus p, 6 is minus p, and 1, 3, 5, and 7 are plus p. So that's basically a matter of going through here and being like, what did I say? Minus p, plus p, and so on. So it's minus p. Let's just copy it. And then we're done.
And plus p. Okay.
So when you just erase that line out of the center, you did mess up your index numbers over here. Too easy. So, and this will come in handy later on if we do the same thing as we did before, if we just line everything up. That's one reason I'm not a huge fan of the auto formatter, because it's like occasionally I'd like all my maths to line up. That'll make life easier later. So let's I think we just have everything sorted for this, so why don't we run it and see? Well, mine is working, and you'll notice that now when you click, you get this little extra bit off the end.
Yep.
So that's the start of what we want to do. So why don't we put some little round end caps on them, hey?
Mm-hmm.
So what we want to do now, first of all, let's just get our texture into the thing.
Yeah, I kind of did that while you were on the.
Way ahead of me. Well, mine is as well. What I will say is, just out of habit, obviously we don't have this color in there, but color key enabled false is usually good. And generate bitmaps, you probably want that to be true in this case.
Is that because we're going to put texture over top of it?
So, well,
I mean, it is a texture. I just mean, like, I guess we would be.
Well,
yeah, tell me why.
That's it. That's an excellent opportunity to talk about what bitmaps do. So, hey, can I have my thing back? Thank you.
I hope that wasn't your tablet again.
That was the pen for the tablet. It's
Okay.
getting some airtime today. Okay, so what we have here is we have a texture that's like 64 times 64, and it is a picture of a circle. And I'll talk about what we're actually going to do at the moment. It should be fairly straightforward. So this incredible picture of a circle. When the graphics card goes to sample from this texture, it's like, I want to draw this, I want to draw it to the screen like over here. And, you know, it's going to draw like a thing that looks like a circle. And so it's going to be like, I want a pixel here. And so when it samples from this texture, 64 by 64, it's going to sample like a pixel here, for like that green one, and then like a pixel here, and then like a pixel here. Now what happens is it's gone and sampled like this one pixel, but this is drawn a whole lot smaller than 64 by 64 in this particular case. So this one pixel here might look like, and I'm just going to sort of roughly guess, look like that bit of coverage. How to explain this? So what the graphics card is going to do is going to be like, right, I want that pixel there to cover this section. I'm going to sample this pixel here. In fact, that's not the best example, perhaps. Still, I'm going to sample this pixel here. And unfortunately, what that means is that it is ignoring the data from like this pixel here, and this pixel here, and this one here, and this one here, and this one here, and all of the other pixels that will be covered by this sampling region. And the reason that's a problem is because, like, let's say for example we had a more interesting thing there. So let's like zoom in on like a small section of image. Let's say this is amazing pixel grid here. Let's say we had like a thick line here, for example, like a completely different texture, and say a thick line here. So if we color in like these pixels, and there's just like this thin sort of white line going through, you know, this massive section of, you know, black. What it's going to do is it's going to sample from this texture, and it might grab like this pixel out and be like, oh, this is white. So when it goes to draw, you know, the thing much smaller, it's going to stick a white pixel there. If you mip-map, what happens is during the texture generation process, it takes this 64 by 64 texture and generates a 32 by 32 and a 16 by 16 and, you know, an 8 by 8 and so on, all the way down to 1 by 1. And so because we're drawing it much smaller, you know, it actually wants to sample from, you know, a section of like 4 by 4 pixels. It's got no way to actually do that sampling on the GPU because it doesn't. Like, it would have to read a whole lot of memory, and it doesn't want to, sample things slowly, I guess. When it says, I want this pixel, it wants to read one pixel and that's it. So what MIP mapping does is like, oh, I'm drawing this like really a whole lot smaller than that. So that's about this much smaller. And so what it's going to do is, it's going to do a smaller one of that. It's going to, this 4x4 section here of some texture is going to be like a 1x1 section of a texture. So there's still a bunch of texture out here. And this 1x1 bit of texture will be pre-processed to contain more or less, and you can like do custom sampling here, but more or less an average of this. And so it'll be like this gray color. And so when you look at this, this image that we've drawn, instead of looking like, say it's got a dirty gray line through it, it's going to be all black. And it's like, this is hard to draw. So it's going to be solid black. And, it's got this really thin line through it. What's going to happen is when it gets drawn without MIP mapping, you end up with like 1 or 2 pixels are going to be sampled like just smack in the middle of there, just out of luck. And you end up with like a whole lot of sort of weird artifacts that will like shimmer as, say, if this texture is moving across the screen or something, or changing shape, you'll get this shimmering effect as the sampling positions sort of, move across this texture. That'll like go black and then white. Whereas if you MIP map it, it will be like, it's like gray, 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 and it'll sort of look a lot better when it's scaled down. So does that make sense?
Yeah, I had a couple questions. One was,
Yes.
right now we're telling Monogame to do this MIP map thing. How does it get the pre-processed, smaller images to the GPU, like in a way that the GPU can just switch between them at will, or how does that? Is that part of a GPU's feature set? Like, it's obviously
Yes.
like aware of MIP maps. Is that all it is? Like, it's like a feature.
That's all it is. What it does is when it says, I'm trying to remember exactly, like, this is a wee bit tricky to explain quickly. Like, this kind of like one lesson, we could spend a whole lesson on this and the maths behind it.
Well, for me, just knowing, that it's sort of like first class to the GPU is probably
it's first class for the GPU, and basically what it does is when it samples this pixel, it knows how it basically knows, it's like, oh, this is sampling from a 4x4 region, so let's step it down till it's a 1x1 region. Oh, that means we need the like 16 MIP map. So it knows the size of the pixel in texture space, and so it knows basically how small to go, if that makes sense.
Yep. And the last question was, does it need to be square power of 2 or something to work, or how does it work if it's weird shaped?
I cannot remember the rules exactly for that.
Doesn't matter.
Because it used to be in the days you could only have power of 2 textures, and that was just the rule. And then there was a time, and this is like, I think the last time I checked, where you could have any size textures, but if you wanted MIP mapping, they had to be a power of 2.
Okay.
These days, I'm not sure if you can actually do a non-power of 2 MIP map, but what I can show you is sort of the obvious problem with that. If you don't have a power of 2, say this is, I'm just going to scribble on this diagram and make it really, really heinous. Say this texture was like slightly bigger. Like, okay, so this is like 66. So it's 2 extra pixels. Then, this one would be
Mhm.
65, that's fine. That's one extra pixel. This is like 0.5 pixels. What do you do with that? And that's sort of the problem. And the way this is sometimes solved is you just blow out the entire texture. So suddenly if you added 2 pixels on the end there, this 64 by 64 texture suddenly becomes like a 128 by 64 texture, and this is all just wasted space. And so that's one way of dealing with it. But even in that case, your MIP mapping algorithm, the sort of the downscaling algorithm, has to be aware of the fact that you've chucked this extra bit of texture on the end, because if, say, the pixels out here, if they were defined to be anything, you've suddenly averaged, like this one's fine, this is only pulling down samples from that section. But this pixel here has to be sampled intelligently to only pull pixels from this section. Otherwise, it's getting whatever bogus data is out over here when it pulls that section. And this becomes even more of a problem because all of the pixels over here are taking samples from like 4. It's taking an average of 4 pixels, and whereas if this does some sort of intelligent sampling and it pulls in samples here, it's going to take in 2 samples. Now, sometimes, and depending on what you're drawing, that's fine. Other times, just due to like statistics and stuff, and this is a little bit beyond me, like I'd have to, if I was ever mapping something bigger, I'd research this. But you might get a weird result in some circumstances, like the color would just be slightly off in that case. And I think it's got something to do with like the sharpness of the image. This is stretching my knowledge here. So like if this line, we're drawing a line like that, you might find that like the color of gray, does this even show up, is just slightly darker on that very edge or something, or slightly lighter, just due to the way it's sampled.
That makes sense. So basically, you don't want to have these kind of like artifacts, especially if it's moving, something you can't predict. The values are sloshing about.
Yeah. So.
I noticed the resize to power of 2 and make square top parameters are in mono games, so I didn't know if they had some sort of relationship.
So I suspect, because I can't remember if you can actually even do this without adding padding to the image. And I suspect when XNA was written, you actually had to add padding, and it was an issue. So you just basically, it wasn't something you do, generally speaking.
Okay.
But yeah, for our purposes, because we're going to take this circle texture and this, this nice, lovely circle texture I made that has like a nice feathered edge, and we're going to be downscaling it because most of our little end caps are going to be smaller than 64 by 64 pixels. We want it nice and smooth. So we'll have the nice smooth inner versions. So let's start adding excuse me. Sorry, let's start adding that texture to our thing. So there's 2 things we need to do here, and then there's a secret third thing we need to do afterwards. So first of all, what we need to do is we need texture coordinates. Let's do that one first, because we kind of need that data. So scroll back up here, and so we have our circle texture. It's a thing that looks like this, and what we want to do is, I was using red for this, so I'll keep using red for it. So we've got our circle, and we want an end cap on either end, and then this middle section we just want straight solid fill. So what we basically want to do is we want to map this shape onto our line, if that makes sense. So the middle section, we're just going to be grabbing from that very thin region in the center, and stretching that out over this whole thing. Now the way
Why would you bother doing that? Why do you need to do that rather than just ignore it and have it draw as it is now?
Because you cannot turn textures off and on in the middle of a batch of triangles. So all of the triangles have to render with the same mode. So that's why we do it this way. So what we're going to do, so texture coordinates basically go from 0 in the top left corner to 0, 1, 1, 0, 1, 1, and 0, 1. And so obviously these ones over here are 0 0.5, 0 and 0 0.5, 1. So hopefully that makes sense of how the texture coordinates work. And so what happens down here is we just have to fill in this data. So this vertex here, it's got a position, and we've also given it a color because we're coloring these lines. Now I just need to give it a texture coordinate. So this one's going to be 0, 0, this one's going to be 0 0.5, 0, and so on and so forth, going around the thing. So does that all make sense? Are we ready to slap that code in?
Yep.
Excellent. So let's go down here. So we've got this vertex position color. So now we know that we need to add to that. So let's go through and find all the usages of vertex position color and fix them up. Because now we need vertex position color texture. So we need to change the data there. Now, before you go too nuts, don't change the one from before. Because just the stuff for our vector-based lines.
That's right. Yeah, this is just our sample code. Right.
So there's that one. There's the vertex declaration, and then there's all the places where we initialize it.
Okay, so you need what? Texture coordinates. Oh, we're just gonna make new textures here. It's not fancy. We haven't given it a texture yet, but we'll do that in load content, I guess, right?
Yes. So first of all, we're just putting the vertex data in, and I mean you can do it either way around, but this one I'll show you, because this one you can have excess data in the vertices and it won't make a difference. Whereas if you need the data in the vertices, nothing will draw. If that makes sense. So 0.5f, 0.0f. Now we need to make sure that all of the the odd ones are 1. Sorry everyone viewing this about the crying child next door.
I don't notice it anymore if that says anything.
That's all right. So now I've just gone ahead and just filled this in, but hopefully what I filled in makes sense.
Well, actually, oh no, I see. Yeah. Okay, it has a pattern that I'm assuming looks like the diagram, so it's good enough for me.
Exactly, it looks like the diagram, and you can kind of get it. It matches this, this minus n minus p plus n. Yeah, it's the same pattern.
Yeah, I see that.
If we haven't made any mistakes, so let's just scroll up to. I didn't see if you got that this stuff up here in load line drawing content. Yeah. So you need to make sure that this one here matches the vertex data we're using, because you recall that when we send this to the GPU, it has no idea the format of the data is just a stream of bits. So we need to make sure we tell it what's in that stream of bits. So now if we run, in theory, we're still drawing, and now these vertices have texture coordinates associated with them. We're just not using them yet. So everything's okie dokie over
Yep.
there. So now we need to use our texture basically. So what we're going to do for this is I'm just going to create a new basic effect just to make things easier for us to and down the road this will be easier too. So let's take our let's scroll up and grab a copy of our basic effect, which is just that. And we'll bring it back down here and paste it in. Where'd it go? So after we set up the vertices and indices, we'll have a line effect.
Mm-hmm.
So there's two things we want to change. So first of all, texture enabled. So you'll recall that this has got a whole bunch of effects built into it. So now we have texture coordinates. We actually want texture enabled. We also actually need to specify a texture. And that is content.load and that will be the circle texture we created before.
Mm-hmm.
So now when we go to draw, we need to use this line effect instead of the basic effect. So there is one thing that I'm just going to point this out for, because when I was running through this, I'm like, where's all my lines gone? And the answer to that question, just to save a little bit of time, is we also need to remember to set the camera, because we set it for the basic effect. Now we need to set it for the line effect, and so doing it here is as good as doing it anywhere. So that should be fairly straightforward. And so now, in theory, we're drawing with a texture.
Just with that alpha blend, right? It's kinda...
Exactly. So, and then that's sort of the next thing to fix up. Is like, what happened to our alpha blend? And this is something we didn't really talk about.
Wait, hold on a second. Why did my red, green, and blue? My red, green, and blue is now drawing with the line effect instead of the basic effect. Is that what I?
Oh, that's because they
Oh
are.
no, yeah, no, yeah, that's correct. Never mind. Yeah,
there are
that's
test
fine.
lines. So now this is something that probably should have thought about before, and I probably should have noticed, because we actually, if you recall, to over here in a bunch of places where we actually draw these lines, we're actually doing this thing over here, this multiplication here, that should be applying some alpha fade, and that's not actually happening. It's just graying it out. So obviously we've forgotten about the alpha blend.
Pre-multiplied, is that the XNA4 has that pre-multiplied alpha that kind of always...
Yes, so we haven't set any alpha blend, and the way you do this is by setting, so the texture is fine, the texture is actually in the correct format, that's imported correctly, but over here, when we go to draw, let's just go graphics device. So this is a setting on the graphics device, and this is one of these sort of stateful things about the graphics device. That,
oh yeah,
you know,
usually the spray batch lets you put this in begin. So
exactly.
Kind of
like, and in fact, so I actually have deliberately made this error just to sort of show what's happening, because I actually made this mistake. I'm like, where's my alpha gone? And so and then I put in, I'm like, well, what happens if I just draw the texture? It's like, oh, it's back. Like, what did I do? I did sb.again sb.end and sb.end Draw circle. Oh, actually, I don't have the texture content dot load. We're really lazy here. Texture 2D.
Is that cached internally, or is that
It
like
does
the
cache
studio?
internally, so it's actually this is actually, I don't think this even allocates memory doing this, so it's a bit slower, but it's actually not a big deal. So you'll notice if I do this, I'll get rid of that thing I just did now. If I do this, it'll draw the circle texture up in the top corner. So it's like, oh yeah, my circle texture is importing correctly and everything. It's like, ah, these have gone and fixed themselves now as well. And the reason is when you go and set things like blend state on the graphics device, it will stay there until you set it again, like until you set something else, which is not too bad. You know, it's fine. So usually what you do is just like, if you want a particular state, you just set it. So in theory, maybe if we were making this a bit more robust, we do the same thing that Sprite Batch does and be like, well, every time we go to draw, I would like the right blend state. Thank you very much. So that's about it. So do you want to run yours and check it works?
Yeah, I'll just do your fun robust thing where you
I'll get rid of the.
threw it in.
I'll get rid of the one up here just for fun, and we'll put it in the finished vector lines. So this is exactly the same thing that Sprite Batch does. It sets it on the end call from what you provided to begin. And now we have these lovely smooth lines with these lovely smooth end caps.
Really cool.
So
I like them.
yeah. So how are we for time? We're pretty much out of time. So
Don't wait for me. I'm just writing math is hard. This is cool.
So yeah, we've got these nice lines with these nice end caps, and as I was saying, so you'll notice if you zoom right in on these, they're not as pretty as they could be. Like you can see the the jaggies, because we're only using a 64 by 64 texture. So if we zoom in higher than 64 by 64, it doesn't look so crash hot. So the texturing's fine. Like that's fine for like a debug view. But if you're using this in a game, you might be inclined to make a pixel shader that instead of maths is fun. It is fun. So you might be inclined to use a pixel shader that basically generated an infinite resolution circle rather than doing this 64 by 64 version. So that's something we could talk about in a later episode. Perhaps we can do a little diversion into pixel shaders. So cool. That's the thing. The other thing I just wanted to briefly mention, because I know it's something that you've interested you, and so for those people watching on YouTube, you'll notice this has like IMGUI as the sort of the name of our source file, and that's because Daniel is interested in IMGUI, which is fine because IMGUI is very interesting, and it's something that's sort of worth looking at doing it. So there's I don't have the website up now. There's a guy that makes a OpenGL version that's C based, obviously working in C#, so we can't use that directly. There are bindings, but maybe it might be the case that someone would be inclined to make their own version. I know that sort of I've given it a lot of thought too. So what we've been doing is building up this vertex data structure. And so I wanted to finish off by pointing out that that's kind of what IMGUI does. In IMGUI, you've got like, you might have, say this is your program, and it's like if, button, blah, do thing. And it's a really, if, no, it's not even if, it's like, label foo. So like this looks familiar as like IMGUI code. So the methods button and label would be IMGUI stuff. So that should all be sort of familiar, yes?
Yeah, I mean, for me, I think, for the audience, like immediate mode graphic user interface, right? It's a cool
Yes.
way for developers to build visual tools, like where your principle is always like you need to be able to see it, right, to develop it in a sensible way.
Yeah.
So this is like a SDK that lets you build UIs very quickly, and it might be used in the game itself, right? There's a lot of games that probably use the
Okay.
UIs they build directly, but you ever seen any of the Witness dev videos? It's a pretty impressive looking development
Yes.
tools.
Yeah, I think actually, John showed a few of them. Casey showed a few of them as well, and I'm not sure it's IMGUI that they use. Maybe I have to actually go and look some more. I know.
And sometimes I forget it's a product name versus like what it's doing. It's
Well,
like what it is.
I think Casey originally popularized this like quite a long time ago.
Okay.
And the name for it. But the idea is basically like this is doing two things. So in your game's update method, so like I'm gonna underline like your game has a do thing method and your game has an update method, and then these green ones are like the library methods. And so this does two things. First of all, it does mouse input, so and like focus tracking and whatever. So it's like when you say if button, that's put a button on the screen, says blah, and if the user goes ahead and clicks on this button with my amazing green cursor, then this if statement will fire because it's handling mouse input, and it will go through, and let your program know that it fired, and so you can do thing. And so this is really like, you can see how little code is involved, and that's sort of the point of IMGUI. And hopefully, like if none of this is making sense for anyone watching, it's like we can link some things that show you why this is such a cool little thing. It's so little code. You're not having to make class button and then like new button and then have like list of UI elements and move the UI elements and delete the UI elements and add the UI elements and blah, blah, blah. No one likes this stuff. It's like just let me write straight through code. It makes it's maybe a little less performant because every single frame you're regenerating the whole UI, but it's like the UI's got maybe 100 elements in it. It's like that's nothing compared to everything else that a game does. So what it's doing is it's doing mouse input, so it can fire this if statement down here. But what it's also doing is this drawing. So while it's seeing if you click this button, what it's also doing is it's doing exactly what we've been doing today. And this is sort of the point that I wanted to get to for you, Daniel. And as we draw a label, what it's doing is it is internally building up a buffer and maybe an index buffer. It's internally building up a vertex buffer and an index buffer containing everything that you call there. And those vertex and index buffers will be like, there's the shape of the button, and it'll be like there's the it might have nice rounded corners, let's say. So like it will generate a mesh that looks maybe something like this.
Mm-hmm.
And and these will have texture coordinates. So like this texture, like these 4 vertices will point into a texture atlas that should look fairly familiar. It's like, there's the texture for A, there's the texture for B, there's the texture for C, there's the texture for D, and so on. Blah, 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 blah. And so when it goes to draw the letter B, it'll be like, give me the texture coordinates that are B. And this is very, this like X and A Sprite font. So it's like a really souped up version of Sprite font, which is kind of like Sprite Batch in a way. And then, for these like rounded corners, like if it's going to go ahead and draw, what are we doing? It's like, here's a nice little semicircle. It also has, I guess it only has to be in one direction, because hopefully you've noticed you can like flip textures by just calling, just specifying the coordinates in a different orientation. So it's got this nice semicircle there, and so it's like, all right, I want a nice rounded corner in my dialogue. Let's stick a little mesh in with that. So every single frame, it sets up these index and vertex buffers, and then when you go, draw, all you have to do is be like, draw UI or whatever. Yeah. And then, this is a method. Draw is your method, but this draw UI is in their library, and this draw UI method is basically the same as our finished vector lines. It's like, let's just set up the render state and everything, and we'll just blast out this, this vertex buffer and index buffer that we've been generating. Let's blast that out to the screen. And so you can do interesting things with that. Like it could be the case, it's like, well, nothing in the UI changed, so we don't need to actually update it. So we could actually, draw it, draw it on 2 consecutive frames without changing it. So, and I guess I'd say to do that, where are we at? What we do here is we actually reset the line count. So it might have a separate method in that, like if it lets you draw it several times off the same thing, it might have its own methods like start UI. There's just resets all the vertex buffers and stuff. And it will probably have to do a few things to start frame, just to get the mouse input as well. So that is more or less how IMGUI works from at least the rendering perspective. If that makes sense.
Yeah, I think I'm assuming because you've only declared button and label in that way, you probably have some way of starting at the top, like how your layout's going to auto flow, and there's probably a bunch of complexity in that too, right?
Yeah, absolutely. So like that's just how the drawing works. Like this bit here is also nice and complex. That's actually probably the harder part, really. There's probably some tricky things in drawing just to make sure everything that generates in the right order and everything overlaps properly and stuff. But that's just conceptually how it works. It's like you can generate these things during an update method and keep them around for as many drawing methods as you need. The way it does this is it's got some internal state tracking. It's like where's the last position I drew. So this updating thing would be like internally to this method. What color? Purple. It's like caret equals 0, 0, and then after this method, it's like caret equals so 0, like however tall this button is, so like 30 pixels, and then it goes onto this label, and it's like it draws it at 30 pixels, and then after this label it's like caret equals 0, 60. So the next thing you draw, like if you draw another label, blah blah blah, it'll draw it at 60, and then the next one will be at 0.90, and so on. So hopefully that makes sense. Like it just keeps that internal state, and then of course, there are overloads for button. It's like button with position, and then you can draw it at your own position, for example. But
that's what I was hoping there wasn't. Size and stuff, style is fine, but I was hoping for auto. Like I would want to do it with an auto flow container, because the last thing I want to do is like mess around with like absolute position coordinates about where I'm trying to put UI. Unless, we assume that everything's going to be top left and it's just going to flow down from the top to the bottom.
That is more or less how it does things, but pretty much any sort of layout system you can imagine that can be done incrementally, like this algorithm here, like this stuff.
Mm-hmm.
Any sort of algorithm that can be done like 1 step, 2 step, 3 step, 4 step, and whatever, it can you can obviously do in the system. Anything that requires you to know the entire content, so if you need to lay out button, you need to know about this label that comes later, then you get into some really complex buffering. So you can't just spit stuff out every single call into the vertex and index buffers. You actually have to buffer stuff up and then generate these at a later step. So usually when you're making an IMGUI system, you try and avoid that circumstance entirely. And either if you ever want that, then it's maybe up to the user to insert some extra parameters in here to deal with that situation. Or you just do the hard work to buffer it up. But I'm trying to think if like the common one that I will link to in the description of this video even has that option. I don't think it does. I think it only will do layouts that can be done directly into the index and vertex buffers.
Well, that's good. Yeah, I see the value of that. Whereas then you're right back to creating like complex UI elements and all that.
Yeah.
So.
Yeah, some of the early documentation, like I think when I first encountered IMGUI, there wasn't a good implementation, and people were like, "Oh, maybe, in the background, like behind the scenes, we'll do all this nonsense for you, this like class and list and blah blah blah." And I think people seem to have landed on the fact it's like, no, you don't want to do that, or at least that's not what you want the default case to be. If the user wants that, they can dick around with it themselves.
Mm-hmm. Or maybe you have some kind of like code gen option that lets you like capture the original thing and kind of bake it into a more plummy version of it or something. If there's some way, in like if you were gonna transition, I don't know why you would, but if you're gonna transition this UI into like shipping game or something, maybe you want to bake it into something a little different for performance.
Absolutely. Like that, I think, is something that that people have done. I'm trying to remember if it was actually what I saw. I think I saw someone was running around with like a graphical way of generating IMGUI code, basically, if that makes sense.
Oh yeah, sure, yeah, right. It would be like Visual Designer, like Visual Studio spits out.
And that's actually the nice thing about IMGUI is that you only need this tautological, as I was about to say, you only need what you need, but it's like you only need the bits that you need. If you need to store some state to track your own positioning, to do your own custom layout, that's like requires knowing about the entire contents of what you're drawing, then you can just do that. Otherwise, you don't even need to worry about it, and you only need that data which is required for that. Whereas in this system, it's like you need to keep track of every bit of data for every single element that could appear.
There's just too many of those anyway. Like, GitHub is riddled with, the graveyard of UI frameworks for games, I think.
Yes. And like if you wanted to make a designer based thing, I mean, you could. It would be really easy to just like parse a document and be like, the document says button, label, label, and it's like, well, call button, call label, and it's just like done. But in that point, maybe you don't want to do it that way. But yeah, for basic UI stuff, and we saw a little bit of this. I didn't do too much of it on River City, but what you end up doing with this is like, I want an inspector for something, and so it's like, what would you do? It's like, I've got some object in the game that's got some fields, and so I just write, inspector for, my object, and then it's like, label that thing, label that other thing, button for, doing a thing to that, and so on. And it's just a really easy bit of code to write. And if I'm just making inspectors and not shipping code, it's like, I really don't mind the fact that this is going to be like line, 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 line. Like, it doesn't have to be all that pretty.
Well, you end up building something that's not pretty anyway. I mean, there's a lot of,
exactly.
Like, if we had done the work of doing sort of like being able to reload the game state, like like level properties is an example. Where do the teleporters go in one room to another? I mean, crap. We end up building the gross UI ever for our own internal tools, except they didn't have the benefit of, you had to kind of build the level, change where the door goes, rebuild the game, go back into the game, go through the door. Did it work? No. Stop. Go back. Change your property. So this is awesome when we want to move away to like making the game engine itself the editor, right? Because now we can just keep flipping through all the options of what levels they are until we get the one we want, and we can do it while the game is running. And that's kind of like the holy grail.
This is the thing. Like, I mean, you can do that same thing with this, but it's a mess. It's an absolute mess. So like, and you can do what we're talking, like what you're talking about, sort of in the same. You recall we had all kinds of like crazy, like you couldn't really save data out of them, but like those key command menu system we had going for like inspecting things and changing the state and stuff. Like that was
just that was by rote, right? I mean, it was super useful, but if you had to build something, you kind of had to go in and do it. Whereas here we can kind of just like throw Glenn in and do whatever we want to.
Like that was powerful, the stuff we had in there, but it was ugly, and not very intuitive as a user interface. So that's the nice thing about IMGUI, is that like it's this really sort of sweet spot for amount of effort required versus how good the user interface looks and feels and behaves. Like it's almost as good as one made up of like a retained system, like really close to that, but it's just so much easier to write, basically. And it's like not really that much harder to write than the stuff we were doing, because you'll recall that was very similar. It's like the code kind of looked like this. It's like if button, if, and then label is almost exactly what the code was.
That's true.
But button was like a keyboard key rather than like a nice graphical button you could go and click on with nice Windows cursor situation.
The question is, how do you? I guess there's a limit to it, though, right? It's not like we could start editing like height maps or something in this without having to build some kind of custom, inspector for our own particular data types, right? Like that we kind of have to build into the engine. But still, even that is not as bad as having to struggle with Windows APIs and like third-party, GUI things to try to get height maps to work in the editor that we have. So.
Well,
Probably choose that every time.
that's actually interesting you bring that up, because that's almost exactly um, that's the extensibility model of this, and it's really nice. And that is like, say we wanted like a height map editor. It's like, height map ed editor. That, it's not one of these green underlined ones. There's not really as such red one. It's like this other sort of thing. It's like, this is, I mean, I guess, it really is a bit of our code, but it operates like one of these. And, there's no reason that these have to be like, private. These can be public enough so that when you go to write your own, editor method, it can go and just write extra stuff into the vertex and index buffers, so it can generate its own user interface here. So if you have like some complicated height map editor control that you wanted to make, that's really easy, and you only have to do so much work as required to spit out the graphics for it.
I regret everything.
Oh dear. Well, anyway, let's
like
before we start regretting things about our game, let's just say Merry Christmas to everyone watching, and we'll shut off the recording. Thanks for watching,
Happy
everyone.
holidays.
Cheers.
Cheers.